All right, with the inverse trig functions, we know that we have to restrict these curves because the horizontal line test wouldn't work. It cuts through lots of times, for example, like that. So we need to restrict to where it's monotonically increasing or monotonically decreasing. So this is what we could do it in a number of different ways, infinitely many different ways, but this is what usually happens, and these are the ones we're going to use. So we're going to restrict the sine curve between minus pi on 2 and pi on 2, and you'll see, so if we do that, if you think about, oopsie daisies, nope, here we go. If you think about all stations to central, we're going from 0 to minus pi on 2, so 0 to minus pi on 2, or minus 90, and 0 up to 90. So we're looking in that first quadrant, the A quadrant, and the C quadrant. So just remember that as you do the questions. So for sine, we're looking between the first and the fourth, just in the first and the fourth quadrants. It fits nicely. If we think of this point here, we've got pi on 2, 1, so the inverse of that would be 1 pi on 2, so here's our 1 pi on 2. This point, negative pi on 2, negative 1 becomes negative 1, negative pi on 2. 0, 0 is still 0, 0. If we then put those together, and if you reflect the curve on y equals x, you can see it becomes, well, that was very difficult to see, but you can see that it becomes this curve below, hopefully. So if I tried it up here and down here, if we just reflect it, we get that curve. So a good idea is to be able to draw these inverse trig curves from memory, be able to reproduce them, because we'll use them when we're doing transformations. So try and remember that. If I jump to the tan curve over here, you'll see we want to restrict it again, and the most usual restriction again is from minus pi on 2 here to pi on 2. So again, we are looking from 0 to minus pi on 2, or minus 90, and 0 to 90 there. So again, in the first and the fourth quadrant. So sine and tan, the inverse sine and the inverse tan, or the restrictions for our inverse trig are the same, except remember these are asymptotes here. So we don't include minus pi on 2 and pi on 2, whereas for sine we are including negative pi on 2 and pi on 2. So if you think of this a point up here, think of it as something like we've gone across to almost to pi on 2 and infinity. So we're going now on the x value across to infinity and almost pi on 2. So you can see that again we've got asymptotes happening here. Or think of our asymptote being x equals pi on 2, so it becomes y equals pi on 2. X equals negative pi on 2, so y equals negative pi on 2. So there are two asymptotes. We still have 0, 0, 0, 0 there. So hopefully you can remember what this curve looks like, the arctan or inverse tan curve looks like, and memorize that one too. So remember the arcsine and arctan, or inverse sine, inverse tan, are both using the first and the fourth quadrants, but tan doesn't include the negative pi on 2 and pi on 2. All right, what about the cos curve? So if we have a look at the cos curve, if we wanted monotonically increasing, we could have chosen this part of the curve, but most of the time we like to use positives. So we're going to use monotonically decreasing instead. So where it goes down, so we're going to use that part of the curve, which is between 0 and pi. So again, if I'll draw it down here, between 0 and pi would be 0 and 180, so it's the first stations and the second quadrant. So remember for cos is the weird one, we're looking in the first and the second quadrants. And we're including those endpoints. So this endpoint being, it was pi minus 1, so the inverse of that would be negative 1 pi. So we have here negative 1 pi. That's in the second quadrant, yeah? So the first quadrant, we have the 0, 1, and that becomes 1, 0. We also have a point here, which would be pi on 2, 0, so that becomes 0 pi on 2. So this point here should be pi on 2. So this thing's incorrect there. This should be pi on 2 up there. All right, so what you have to learn to do is to draw each of those 3 curves from memory with just the important points on them. Good luck.